students, welcome back 9th class. Today I am going to wind up with the chapter Matter and Our Surrounding. In my previous videos I have uploaded 2 videos and today is the third part in which I'll cover sublimation and evaporation. So chapter will be wind up here. Now, what is sublimation? It is a physical process. It is a physical process in which in my previous videos, I have told the change of state, that is solid converts to liquid and liquid converts to gas. This is how we have studied on cooling and on heating. These are so many conditions are there. But when I am talking about sublimation, then what happens? The solid directly converts into gaseous state without changing into liquid state. Yes, student, solid to gas without changing into liquid state. So, which are those substances that is undergoing sublimation? Sublimation, few substances are there which what converts like this. Like for example, if I say naphthalene, ammonium chloride, anthracene, camphor, these are so many substances. That means what is the condition for this process? The substance has to be sublimatory. All the substances will not do this. Only the sublimentary substances, those can convert directly solid into gaseous state. Like camphor. Camphor, that is kapoor. Now when you are heating it or burning it, what happens? That solid white color will directly convert into gaseous state. Naphthalene balls, these are the small balls which we'll use in the clothes and all for disinfectant and all. So what happens? After 1 month, if you see those balls, that will become a little smaller, very small. The time comes when it vanishes. So this is very important part. The substance has to be sublimentary, then only this process will take place. Clear? So come experimentally, how will we do this? The diagram is very important in your exam. Explain the sublimentary process using diagram, well-labeled diagram. So come here, let me explain this here. We will take a watch glass. This is the burner and we will put what? Inverted glass funnel on watch glass. And we will put the powdered ammonium chloride so that the process could take place faster. When I provide heat by using burner, what happens? This sublimentary substance, that is ammonium chloride, will directly convert into gaseous state. Gaseous state. This is the gas. Clear? So, gaseous state, and we will plug here at the mouth with the cotton plug. Cotton. Okay, we'll use cotton over here to plug that so that the gas will not escape out. So on heating, this ammonium chloride directly converts into gaseous state, and then what happens? Then what happens? Here the gas could not able to escape. Now the gas gets cooled over here. And then again gas converts directly into solid state. Conversion of gas. This is not sublimation. Sublimation is conversion of the solid particle directly into gaseous state and then it reaches here. Now the gas cannot escape because of the cotton plug. Now gas on cooling again converts into solid ammonium chloride and deposits here. This process is known as deposition. Deposition. Here again the liquid state is not attained. Sublimation, the liquid state is not attained. So what is the difference? In sublimation, solid directly converts into gaseous state. Clear? We will not say vice versa. Converts into gaseous state on heating is sublimation, and what? The gas directly converts into solid state without changing into liquid state on cooling is known as deposition. This is deposition. Clear the difference between sublimation and deposition? Okay. Now another very good example is there, solid ice. What actually the solid ice is and why it is called ice, why it is so cool. Now what we see here, what is solid ice? Solid carbon dioxide. Solid carbon dioxide, it is solid carbon dioxide which is stored under high pressure. Stored under high pressure. Now what happens? It is stored in somewhere high pressure, the solid gas, the carbon dioxide gas which is being solidified under high pressure. Particles came closer under high pressure and it has been stored. What happens next? When it gets converted into gas, what we do? Decreasing the pressure to 1 atmosphere. If we start decreasing the pressure, the particles will little far apart. The solid particles, solid CO2 in which it starts little far apart and then directly converts into gaseous state without changing into liquid state. First, we have to store the solid carbon dioxide under high pressure and then we will decrease the pressure with 1 atmosphere and then what happens? That solid carbon dioxide directly converts into gaseous state. So, why it is a case of sublimation? No liquid state is attained. Clear? And why it is said solid ice? One, it is similar to that of, seems to be similar, that is transparent. And it causes cooling. It causes cooling. That is why it is known as solid ice. Clear? So this is clear. What is sublimation? What is deposition? And what are the examples? And the condition, the substance has to be sublimatory. Then only this process will take place. Right? Now the next topic is evaporation. Clear? Sublimation is clear to you? Now evaporation, very important. What actually the evaporation is, already you all know from earlier classes it was there. But in 9th section you have to be, there is some very small difference between. See, I am telling you. What actually the evaporation is, it is the process of converting liquid into its vapor state below its boiling point. Below its boiling point. Now very important. See, come, already in my previous video I have explained how the liquid gets converted into vapor state. First it starts vibrating, then collides with each other, gains the kinetic energy, and that heat energy overcomes the force of attraction between the liquid particle and get converted into gaseous state. Clear? So what happens then? Evaporation, it is the process of converting liquid into its gaseous state below its boiling point. Very important. And it is the surface phenomena. Surface means only the surface particle goes on continue with evaporation, and what is going on inside the water? These all happens inside, so that gradually it evaporates from the surface. Boiling is not the surface phenomena, it is the bulk phenomena. In boiling, all the particles are taking part for this process. And evaporation, the surface particles slowly, what happens? Converts into gas. So what is the difference between evaporation and boiling? Evaporation is a surface phenomena and boiling is a bulk phenomena. In boiling, all the bulk of the particles are taking part during this process. Evaporation is slow process, boiling is fast process. Clear? Evaporation causes cooling. I'll explain you right now. Evaporation causes cooling, boiling does not cause cooling. Evaporation can take place at any temperature. Boiling, the temperature is specific, fixed, only at that particular temperature. Suppose if I am talking about water, so 100 degrees is the boiling temperature of the water. So every substance has its own boiling or melting point. So boiling takes place at specific temperature. Again I am repeating, boiling and evaporation. Boiling is fast process, evaporation is slow process. Boiling is surface bulk phenomena, evaporation is surface phenomena. Boiling does not cause cooling, evaporation causes cooling. Boiling, specific temperature is required, evaporation can take place at any temperature. Clear, student? Now, how the evaporation causes cooling? What happens? Suppose evaporation, what happens? If I see like this, wait. If I say in evaporation, what happens? Suppose this is the surface phenomena. This is the surface. Now, when the evaporation is going on, this space is what? This space, there is the space when the evaporation goes on. In that space, it will gain energy from the surrounding. Particles of liquid during evaporation gains energy from the surrounding to regain this lost energy, the energy which is lost in the form of heat and vapor. So this space which is here after evaporation, that time, only that moment only, what happens? The particles of liquid here during evaporation, the next particle of liquid will gain energy from the surrounding to regain the lost energy, causing cooling. Causes cooling. Clear? Here I have mentioned how the evaporation causes cooling. 2 marks question. In open vessel, the particles of liquid during evaporation gains energy from the surrounding to regain the lost energy. Clear? Causes cooling. This absorption of gaining of energy causes cooling. So many examples are there. For example, what happens when you put acetone on your palm? Acetone, that is nail polish remover. If you put a little drop of nail polish remover on your palm, then what happens? What happens? It starts evaporating, and that surface from where the evaporation is going on will gain the energy from the surrounding to regain the lost energy. Lost energy, that is, it is evaporating. To that space will cover, that means that space, in that space, what? Gains energy from the surrounding to regain the lost energy, which is evaporation due to heat, and what? That space now causes cooling. That is why putting acetone on your palm causes cooling. Second point, after hot sunny day, why do people sprinkle water on roof or ground or on the ground? Again, when sprinkling is going on after hot sunny day, very hot, so what happens? Heat energy will release in the form of vapor. So that energy, when it is releasing, and that particular area, it will regain the energy from the surrounding to regain the lost energy. It will gain energy from the surrounding to regain the lost energy. These lines you will write. This is the most important gist which you can use in any of the answer. Clear? So, why people sprinkle water on roof or ground? Because when they are sprinkling, the energy is lost, and what? Due to evaporation, the energy is lost, and that is what? That gains, those particles gains energy from the surrounding to regain the lost energy, and that energy will cause cooling. Again, next question. Why body gets cool after sweating sitting under a fan? When you are sweating, what happens? Evaporation is going on, and that particular area gains energy from the surrounding to regain the lost energy which is going on, evaporation, and causes cooling. Simple, student. This is the main lines which I have to learn. Causes cooling. Next is why the earthen pot becomes cool when the water is inside during hot day. Clear? Earthen pot, matka, you all know. Now what happens? Earthen pot which is very fine pores in it, that pot. Now from that pores the water starts coming out and keeps on evaporating. And when the evaporating is going on, that particular area gains energy from the surrounding to regain the lost energy and causes cooling. That is why water inside the pot becomes cool. Clear? Next is why we are able to sip hot tea from the saucer than a cup. For this is not this reason, not causing cooling. Now come, what are the factors which are affecting evaporation? Factors affecting evaporation is first temperature. Greater the temperature means greater the heat provided, more faster is the evaporation. More the wind speed, more faster the evaporation. Wind will absorb that. Clear? Next is Surface area. More is the surface area, more is the area which is getting, area is distributed. Then what happens? Evaporation becomes faster. When you are drying the clothes on hot sunny day or any time, you are spreading it. If you squeeze it and keep it like that, which will dry faster? The spread one. Because the area is more, the faster is the evaporation. Because every area the evaporation is going on. If it is squeezed condition, only on that area, outer area, that will only get evaporated. Inside it will keep wet only. Right? Next is humidity. Again very important. Humidity. Humidity, the presence of water vapor in atmosphere is known as humidity. Now humidity, the evaporation rate is faster or slower? Slower. Because in humidity, the water vapor is already there in the atmosphere and it will not allow that evaporated water to release out because it has been blocked. The water vapor can't release out. Because already there is water vapor in air during rainy season. This is known as humidity. So, evaporation rate is slow. Clear? So, these are the four factors. Temperature, wind speed and surface area will increase the rate of evaporation and humidity decreases the rate of evaporation. Now come to this question, why we are able to sip hot tea from a saucer than a cup? Saucer which is flat, that is more is the surface area and it becomes much cooler faster due to evaporation is faster because of surface area. So it will be easier for to drink from the saucer than a cup. Because in cup only the surface area is evaporated. Saucer, it has been spread and increased the surface area. Clear? Next is why during summer days why we are wearing cotton clothes. Because cotton clothes have small pores like the earthen pot. Small pores in it which will absorb our sweat. Right? And when it is absorbing our sweat, what happens? It will gain energy from the surrounding to regain the lost energy and it causes cooling. So these are so many questions related to evaporation. Any other question you want to ask, you please ask me in the comment section. So please like, share and subscribe 9th class. This chapter is over. Right? Next, I'll continue with physics or bio. Okay? Thank you so much, student. Thank you.